Hi there, welcome to a quick video tutorial on sine functions. In this video, we're going to apply transformations to sine functions. This video will require you to know a little bit about transformations, which you've probably seen in previous studies. I'm going to just quickly go over them with you. So what I want you to do is take a look at this general equation here and compare this to the general equation for a parabola in vertex form. The transformations are very similar. We're just taking them, applying them to sine functions. So the first one is this a parameter. This is what's called the amplitude. It's similar to the vertical stretch and compression in a parabola in that you're either you're grabbing onto your function and you're stretching it in the vertical direction, or you're squishing it downward, kind of like a slinky. This d parameter is what's called the phase shift, very similar to horizontal translation in that you're moving left and right. And the last one that we're going to look at is the c parameter, which is the vertical shift. This is the exact same as a vertical translation, just moving up and down. Okay, so if the a value is negative, same thing. You've got a reflection over the x-axis, just like you would for a parabola. All right, so if you need a little bit of background on that, feel free to pop into some other videos and jump right back in. Just a quick example to just get us started here. If you take a look at the sine function, there's multiple transformations involved. I've got an amplitude here of 4. That's my a value. I've got a phase shift of 90 degrees to the right. Remember, phase shift is just like your horizontal translation. And the last one I've got is a vertical shift of 2 units up. Okay, so you should be able to pick out transformations just looking at a function. That's going to help you when it comes to graphing the functions. All right, so a couple examples here. Sketch a graph of each function for one full cycle. State the domain and range. So what I have here is I've got a sine function that's been shifted to the right by 90 degrees. Remember that has to do with your d parameter. It's the same thing for quadratics. If this is a negative, it's actually telling you you're moving to the right. If it's positive, it's telling you you're moving to the left. So this is going to be a shift of 90 degrees to the right. So what I've done is just graphed the original sine function here. If you're not sure about how to graph this, pop into one of the other videos that'll show you how to do that. I'll link it to this video maybe. What I usually do is I start at 0 and I end at 360. I know that that's a property of the sine function. Halfway in between, I hit an x-intercept at 180 degrees. And halfway in between there, I hit my maximum at 1 when I'm at 90. And halfway in between 180 and 360, I hit my minimum at -1. That happens at 270. So what I'm going to do is I'm just going to take that function, the basic sine function, and I'm going to shift it to the right by 90 degrees. All right, so that's my phase shift. What I'm going to do is just pick up that function, and if you just picture each point on the graph moving to the right by 90 degrees, on my scale, 90 degrees would be 1, 2, 3 squares. Okay, so each point is going to move 1, 2, 3 squares to the right. So you can kind of picture where these points are going to end up. So I'm just going to pick up this graph and shift it. 1, 2, 3. So obviously I've got the benefit of having technology here. If you don't have technology, you can just do this one point at a time. You can just kind of grab the point and say, well, that one's going to be here. This one's going to be 1, 2, 3 here. This guy's going to be 1, 2, 3 here. This one, 1, 2, 3 here. You can see my graph's actually not entirely accurate. 1, 2, 3 here. All right, and then you can just connect those with a nice smooth curve. So that would be how you would translate that graph 90 degrees to the right. The domain has not changed. I'm still working with any number in the real number system. So as long as I have an x, I can sub it in and get a y. My range should be any real number. Right, so I'm going to have any real number. The only condition here is that y has to be in between -1 and 1. Right, and you can see that on the graph. Sorry, I'm kind of having trouble with my pen here. You can see that on the graph that the maximum value is 1 and the minimum value is -1. All right, so that should be my range. I don't have any y values outside of there. All right, so I've got another example here. I'm going to start just by graphing the sine graph very quickly. Remember, if you start at 0 and end at 360, that's your full cycle. It takes 360 degrees to go through one full cycle. Halfway through 0 and 180, I reach my maximum of 1. Halfway through 180 and 360, I reach my minimum of -1. Okay, so you can kind of see where this sine function is coming from. I'm not going to plot it in its entirety. I just give you kind of a rough idea of where it is. So that's kind of what you're going to see. This guy here is being shifted up by 1 unit. And if you think back to our list of parameters here, that's a vertical shift, similar to the vertical translation of when we graphed parabolas. You're going to just take each point on this graph and shift it up by 1 unit. So my original point at 0 will be now at 1. This guy here was at 1, is now at 2. This guy was at 0, is now at 1. This one was at -1, is at 0. And this one was at 0, is now at 1. Okay, and you can kind of just connect these with a nice smooth curve. I'm going to do my best with my pen here. I'm having a little bit of difficulties, but so far so good. And you can kind of imagine that the sine graph would look something like that. That's actually not a bad sine graph. Your domain in this case has not changed. Remember, any real x value will work here. I can pick any x value and I can substitute it into my equation and get a y value out. So my domain should be any real number. My range is going to be any real number. I can get any y value as long as, and you can look at the graph, you can see here, it caps out at 2 and it bottoms out at 0. Right? So I should specify that in my range. I can say any y value counts as long as it's in between 0 and 2. Right? And I specify that by saying y is bigger than or equal to 0, but less than or equal to 2. You can see that on the graph. All right, so last one. This guy here is if you think back to the list of parameters, I've got what's called an amplitude of 2, which is similar to the vertical stretch or compression. I've also got a reflection here. So I'll show you how to do this one. Again, usually you start with your sine graph, which I won't go over because I've done that twice at this point. But you know, it kind of looks like this. Instead of having my normal amplitude of 1, right, going up to a maximum of 1 and a minimum of 1, I'm going to go up to a maximum of 2 and a minimum of 2. That's the first thing that's happening here. So I've got my amplitude of 2. I've also got a reflection. So what I like to do is tackle these at the same time. So I'm going to take all my y values and I'm going to multiply them by -2. So if I take this first point, which was at 0, and I multiply by -2, nothing happens. All right, so I should be starting here as well with this new function. I've got a y value of 1, which is my maximum. I'm going to multiply that by -2. So I have a reflection over the x-axis, and I also have a stretch by a factor of 2. So my point is now down here. Okay, this guy was at 0. He's not going anywhere. This one was at -1. So I've reflected it over the axis and stretched it by a factor of 2. So it's way up here. Okay, and this last one, which was at 360, is not going anywhere because that was at 0 as well. Okay, so you can kind of see that I've reflected my sine graph. It's also gotten much taller, which is because of the amplitude, right? So I'm going to try my best here to kind of connect. You know, I actually missed that point. It should be at 270 right there, and come back down like this. Right. So I kind of messed up that one, but that's okay. That's an easy fix. Right. So something like that. You can just ignore this part of the graph. But that would be my reflected sine graph. So instead of going up to its max, it now goes down to its minimum, similar to if you had a parabola and you reflected it. Right? Instead of going up to a max, it's going to go down to a minimum. Okay, my domain, I'm just going to rob my domain from my previous page because it's not too bad looking. I should have the same domain in this case because any x value will count. Right? I can substitute in any x value and I shouldn't have a problem there. When it comes to my range, again, with sine functions, you kind of have to be careful in that you're not always going to have every real number. But you can start by saying you've got any real number as long as you specify. In this case, we're going to reach a maximum of 2 and a minimum of -2. So I should reflect that in my range. So I'm going to say -2. I'm going to put my less than or equal to signs with my y, and it's going to be less than or equal to, if I could get this pen to work, here it is, to 2. All right, so my range should specify that only the y values in between 2 and -2 will work for this function. Okay, that brings us to the end. I'm hoping you kind of have an understanding of each of the parameters and the effect they have on the sine graph. You know, the hardest these things can get is when you start combining all the transformations into one. We didn't cover that in this video just for the sake of time, but if you have a good understanding of each of these, it shouldn't be a problem. All right, thanks for watching.